All right. Bum, 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 bum. All right, let's see here. 29 seconds left. I need to get a mat for my mouse. This is too noisy. 13, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, let's see. Let's take a look. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. Okay. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, which is your puzzle input. For example, consider the following list of section assignment pairs. Okay, 2 to 4, 6 to 8, 2 to 3, 4 to 5. Okay. For the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 to 4. So 2, 3, and 4. 4 inclusive, while the second elf was assigned sections 6 to 8. So 6. Okay. The elves in the second pair were each assigned 2 sections. The elves in the third pair were each assigned 3 sections. One got sections 5, 6, 7. The other also got 7 plus 8 and 9. Okay. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of section assignments look like this. 2, 4, 6, 8, 2, 4, 6. Yep, that makes sense. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 to 8 fully contains 3 to 7. 6 to 6 fully contained by, yeah, okay. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning, so these seem like the most in need of reconsideration. In this example, there are 2 such pairs. Okay, and how many assignment pairs does one range fully contain the other? Okay, so we know this is our sample input. Let's take this. And that's our sample input. And we know that this is supposed to give... What was the question again? Was it supposed to give 2? Yep. Okay. Cool. And we can see that that fails spectacularly. Okay, so just make sure that we are looking at cool. Okay, so nothing there. Let's just run through it. It prints those pairs. Excellent. Okay. So elf1, elf2. So we're gonna do for L in line. Okay. Oh, I have to use. Okay. Fuck. Excuse me. Wow, this is. I got some key mapping issues going on here. Oh my god. Okay. Okay. So let's split it by the comma, and then E1 start, E1 end, E1 dot split by dash. Yeah. Gotta just get on it, right? Okay. Oh man, this is getting frustrating. Okay, so then we have E1 start E1 and E2 start E2 and this 4xn. I'm not good at doing stuff like this under time pressure, apparently. Okay. Okay, let's just make sure that we're not doing something stupid here. Yep, okay, we got it. Okay. So if one is God dang it. Okay, so if one is contained within the other, so okay, E2 span is E2 end minus E2 start. Doesn't matter that there's a same for one. Okay, so if E1 span is greater than E2, if they're the same. Okay, so if E1 span is greater than E2 span, smaller is so E2 start E2 end. This is stupid. There's no way this is the smartest way to do this. Okay. That should not happen, right? Okay. Okay. So if smaller start is greater than or equal to larger start and smaller end is smaller than or equal to larger end, then counter increases. Count equals 0, 0. 3. That didn't work. Okay. Oh, okay. So we do have ones where that are the same size. Okay. That's true. We may have that. Okay. Oh, did I get my input? No, I did not. Get my symbol in. No. Okay. Prot. Yeah, Python prot. So 551. Okay. Uh-huh. Yep. 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 So does it say it was too large or too small? If you're stuck, make sure. Please win 1 minute before you guessed 521. Cool. I have some kind of edge case going on here. Okay. What could that be? So get lines. Is it some kind of stupid typo? Start and start and start and E2 span and start, E2 span and start. If so that one. Smaller start, larger start. So that's the larger span. Okay, so that's the containing one. Yeah, that's right. And that checks out, so it goes, okay. I can't do the visualization because the numbers are way higher than that. In how many assignment pairs does one range fully contain the other? L. No. What if they're the same? Why am I discounting that? How about that? How does that work? So part A, that should still check out, okay. And right. Yep, don't care about the breakpoint anymore, just give me the results. 571. Sure. Doink. Alright, part 2. There's still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. Okay, in the above example, the first 2 pairs don't overlap, while the remaining 4 pairs do. So in this example, the number of overlapping assignment pairs is 4. Okay. So we know that this needs to be 4. So that means that I guess the difference here means that. Okay. Okay, so. So if there's any overlap at all. So if E1 starts, no, the two middle ones. So E2. Okay, so if E1 start, okay, if E1 start, is smaller than E2 start. And E1 end is smaller, no, greater or equal oh, no, this is way easier. Okay, so if range E1 start, E1 end plus 1. If there's any intersection between the range from E2 start to E2 end plus 1, then that's okay. Beat. No. Why not? 0 equals 4. Oh, it's still return. It's not. No, it is return count. If range E1 start, E1 end, E2 start, E2 end, intersection. What? Untype none. No, it's part B, day 4. Okay, I have some kind of error. C output frick. This is not my day. Are they mismatched? They are mismatched. Okay. Part B. None type, none. What's going on? I don't get it. I have a breakpoint in. Did I not save that? Oh, it's still looking at sample. So what's the problem? This is gonna be something real stupid in it. I have another. Oh god. Oh god. Okay. Okay. I can do this. I can do this, guys. I can do this. Too many arguments, my foot. No, I don't care about that. I just want the answer. Alright, that was it. Yeah, that was terrible. There's no way I made the hit list, right? No, 3 minutes 22. Most certainly did not. Oh man, that should have been, especially after yesterday when we were playing around with sets. This should not have taken this long. Okay, so now that we have that insight, let's see what we can turn this into. So okay. Yeah, this is terrible. All right, so we take, well, actually, let's just do this. So set range from E1, start to E1, and +1, because it's an inclusive one. Okay, so if either one is a subset of the other, then we increase the counter by 1. That should get the same result, right? B and A, yep. No? Okay. What happened now? Invalid literal. Okay. Yeah, that's not supposed to happen. Oh, right, because that's supposed to be like that. Yeah. Yeah. Day 4, Python prod. Yep. Cool. Okay, so what we did here was just, let's see if we can open them up at side by side. That would be handy. Neat. Okay, so let's see. We have the challenge over here, number 4. Okay, so we got these assignment pairs, and they were spans of stuff that the elves needed to clean. It took me a while to get there, but realizing that these are, again, just like yesterday, these are set operations, and as soon as I got there, it was suddenly very, very easy. This is how I awkwardly split up the input data. get elf1 and elf2, whatever they're doing each. Then I split each of those by the dash that's in the file. And then I map all of those strings that I get, map them into integers instead, storing them in E1 start, E1 end, E2 start, E2 end. And then I create sets based of them. So basically, if for the first couple of ones, so sample 2 to 4 and 6 to 8. So this range function would give us 2, 3, 4, and this one would give us 6, 7, 8. You know, just like we see right here, 2, 3, 4, 6, 7, 8. And then it's a simple question of just asking the set type if either one is a subset of the other. And down here, we're doing the exact same thing. All the code up until here is the same, and the only difference here is we check if there's an intersection. So basically this, so set, once again, we create the, well, hang on. No, we have E1 span intersection E2 span. That should still give us the right result. Part B, indeed. Okay, so yeah, I create those spans just like up here, and then we check if there's an intersection. And if there's an intersection, that means that there's an overlap when it's a range. And that's it for day 4. Yeah, doing this live is hard. You know, having to think at the at the same time. Yep, that's it. All right, thanks for stopping by. Like and subscribe.